Okay, so welcome back. Now, as promised, we need to download now the rock, paper, scissors dataset to our local environment. And just in case you don't have it already, then of course we simply specify ds_train. So dataset train in this case, again, is equal to tfds, which is TensorFlow datasets. And then we say .load. And we already know that we need to specify the name of the dataset. So name is equal to, and I'll say rock, paper, scissors. And when we also specify the split is equal to train. Okay? And we do the same for the test. ds test in this case is equal to tfds.load. And now again we refer to the name of the dataset is equal to rock, paper, scissors, of course in quotes, single or double quotes, doesn't matter. And then we also specify here the split is equal to, and say it's the test this time. Okay? So far so good. We can run this, and you can see I'm done. That is simply, it worked a little bit faster for me because I have downloaded those before, so they are already available on my local drive. In case that's not the case for you, then probably you would see a progress bar, as we have already seen when we did it in the downloading in the cloud on Google Colab. You can see progress bars, and it takes a little bit of time, but it should be fast, depending on your internet connection, of course. So, okay, we got the datasets back in action, and now we can specify. Let's actually take a look at what we need to do. Of course, we need to resize them in this case. Why is that? Remember that the rock, paper, scissors dataset has images with a width and height of 300, right? But our network will actually need input shape, as you can see here, 32 by 32. So we need to reshape our dataset in this case. So basically the images, make them smaller to 32 by 32. So that's what we do here. So we create, again, loops here, or list comprehensions, actually. No. So let's say train images in this case. Let's say train im is equal to, and I say tf.image.resize. So there is an image.resize option in TensorFlow, which we can use here. And we can simply specify, okay, we want to resize the image. And we need to, of course, refer to image itself, image, remember, because the rock, paper, scissors dataset has images and labels. And we only want to resize the images, not the labels, right? Otherwise, we would return an error. So we say from the image, the image itself, so we say size is equal to, and what size? We want to have 32 by 32, because this is the input shape here. And then we also specify here, in this case, we close this here. That's what we want to do. We want to resize it, and now say for image in ds_train, right? ds_train. As you can see here, that is why I'm referring to image here. So if you name this banana, remember banana, then of course you would also put in here banana. Okay, so it's just a name, and here we go. And we do the same for test. Let's say test images is equal to, and say tf.image.resize, and I'll say image. Again, we're referring to, in this case, this image here, image, image, here we go, and say then, again, the size is equal to 32 by 32 pixels, and then we can close this parenthesis here and say for image in ds test. Okay, so we do exactly the same. We basically resizing the images in the training dataset, so as in the test dataset. And let's actually run this. Just a second, will take a little bit of time, so we're done. Okay, that's fine. So we have resized the image to the specific image shape, right? And we can also, by the way, can take a look at that. We'll do this. Let me actually first do another kind of transformation, because we also want to convert this into NumPy arrays. That's also what we want to do. So something kind of similar, which we've done before, when we dealt with the training set in the cloud on Google Colab, but this time we will use 3 color channels, not 1 but 3, because as you can see here, this model in this case accepts 3 color channels, so RGB instead of only 1 color channel. So here we say train images is equal to, and again it's a list comprehension here. Let's say it's np.array. I put this into array and say example.numpy. NumPy converts the tensor into a NumPy array for example in ds_train, like that. It should be fine. And we do the same then from the labels here. We say train labels is equal to np.array again, and say here example NumPy example label. Where is it? Example label. Okay, here we go. example label train im. There's a mistake here. That is why I was kind of confused here. It's called image train im. Sorry, train im, right? So like that. So basically, for example label, that's fine here. Example label, and then say for example in this case ds train. Okay. So please be aware here, this example.numpy, we don't need to specify the image because we're referring to train im, which is this step here. For the labels, on the other hand, we need to refer to label because we are referring to the train dataset, which contains of images and labels. Okay. So we'll do the same for test. So it's a test images is equal to np.array, and again referring to a list comprehension here, and say this is example or banana dot numpy, and say for example in, and now say test images. So test im. Oh, sorry. Let's actually do it here. Spell this correctly. Run this again. Okay, and say also test im here. Okay. So far so good. And then we say the test labels is equal to, again, it's an np.array, and we're referring to the example label like that, for example in ds test. Okay, so far so good. That should work. Let's actually run this. Okay, here we go. And now let's actually take a look at the image, as I said before. Now if we refer to the train images, because now we got a numpy array and we can simply specify 0 and then .shape, just to make sure that we got exactly the shape which the efficient net, which we created, our own customized pre-trained network needs. So we can run this here, and we can see we got 32 by 32 by 3. So because we resized it to 32 by 32, and we kept all the dimensions. As you can see here, we did not, for instance, specify only the last color channel. We kept all 3 of them. Now all our shapes in the training dataset or images are basically 32 by 32 pixels and kept 3 color channels, which is exactly the shape which we need up here, right? Here, for our network. So that is good. Okay. So that's basically the pre-processing we need. And then, of course, there are a few additional things like whether we want to convert this into floats, so make sure that our network really works with this data set. And we also want to then normalize the data just to make it easier for training the network. So we simply say the train images is equal to train images, in this case, .s type. And now we specify float 32. And we do the same for the test images. So test images is equal to, and I will simply specify here, it's test, not trest, but test images dot as type float 32. Okay, sorry for my spelling here. And then of course we want to normalize them, so say train images divided equals, in this case, 255, and also the same for the test, so test images divided equals 255. So basically, it's the same as test images equals test images divided by 255. Okay. So let's actually run this again. Okay, here we go. So we got also the normalizing of the data. And now finally, of course, we can fit our model and also evaluate the model. But this is something we're going to do in the next video. Until then, best guys.